always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it.
Our target calculates variance and standard deviation of ungrouped data. So, we have a variance is defined as the quotient of the sum of the square deviation from the mean divided by n. We have the two formula. We use this one if we are using a population. We use the other one if we are using a sample. Then we have this one. So sigma squared is the variance, n is the total number of observation, x is the row score, and x bar is the mean of the data. So we will now find the variance. So we have the following scores: 60, 62, 73, 75, 76, and 80. So we have summation of x. Summation of x is 426 and 6. Then we will find a mean. The mean is summation of x over n. That is 426 divided by 6. So we have a mean of 71. We will subtract the mean from each of these four. 60 minus 71, 62 minus 71, and so forth. So we'll arrive at 11, 9, 2, 4, 5, and 9. We do not have negative result since we are dealing with absolute value. We have 11 times 11, that is 121. 9 times 9 is 81. 2 times 2 is 4. 4 times 4 is 16. 5 times 5 is 25. And 9 times 9 is 81. So we will find summation of the absolute value of the score minus the mean square, and it can be written as the summation of the square. So, how do we find summation of the square? We will add 1 to 1 plus 81 plus 4 plus 16 plus 25 plus 81, and the result is 328. We are now ready to find the variance. The formula in finding the variance is sigma square equals summation of the square over n. So what is summation of the square? That is 328. What is n? N is 6. So 328 divided by 6 is 54.666. Or if we round the result to the nearest hundreds, the result is 54 and 67 hundredths. Standard deviation is the average of how far the scores are from the mean. It is the square root of the variance, the most reliable measure of variability. The formula is, we have this formula, right? And we have also this formula. One is used when we are using a population, and the other one is used when we are using a sample. So where SD is the standard deviation, X is the individual score, X bar is the mean, and N is the number of score. So we have the following formula. This is the formula for the variance. So we can make use of our denominator as N, or N minus 1, N for using a population, N minus 1 for using a sample. For the standard deviation, we have this formula. So we have the variance. We only extract the square root of the variance, and that is already the standard deviation. This is for the population, and the other one is for the sample. So important points regarding the calculation of the standard deviation. The standard deviation SD cannot be negative. The standard deviation if the set of data is 0, if and only if the observations are equal value. The SD should have a value which is equal to approximately 1/3 of the range. The constant is added to each observation in the score data. Then the SD of the new set of data is the same as the SD of the original data. So we are ready to find the standard deviation. We we have the set of scores. First, we find summation of x. We add all the scores, and the summation of x is 426. What is n? N is 6. We find the mean, 426 divided by 6. The mean is 71. We subtract the mean from each of the score. Then after that, we find d. So, in finding d, we do not have negative result. So, we have 11 times 11, that is 121. 9 times 9 is 81. 2 times 2 is 4. 4 times 4 is 16. 5 times 5 is 25. 9 times 9 is 81. We need to find the summation of the absolute value of the score minus the mean square. Or it can be written as the summation of the square. How do we find the square? We add 1 to 1 plus 81 plus 4 plus 16 plus 25 plus 81. And that is equal to 328. So, we have the formula in finding the standard deviation. We have the square root of the summation of the absolute value of the score minus the mean square over n. Or it can be written as the square root of summation of t square over n. What is summation of t square? That is 328. What is n? N is 6. So we have the square root of 328 divided by 6. We divide 328 divided by 6. The result is 54.666. Then after that, we extract the square root of 54.666. The result is 7 and 3900ths, and that is our standard deviation. Do not forget that if the denominator is n, we are solving for a population. But if the denominator is n minus 1, we are solving a sample.